So in previous classes, we discussed the first chapter of the Camber's book, third edition. Okay. And you were advised to go through the book, right? So today I shall discuss few slides from the second edition of the 10 book of the introduction chapter. Okay. So in these slides, we have some good examples how data mining problems are formulated. So these slides, they are from the 10 book of the second edition, first chapter. Okay. So few slides are here very interesting, and most of the material that I have already covered in earlier classes. So in this slide, few images have been shown, and basically the images, they refer to the applications where large data is being generated and available. Cyber security application, in e-commerce, we have lot of data, transaction data, then traffic pattern, okay, and social networking site like Facebook, Twitter, etc. Sensor network, and some simulation software, computer simulation. So all these are the applications where tremendous data are being generated. Okay. So these data can be used to extract some hidden knowledge. So I read this one. There has been enormous data growth in both commercial and scientific databases due to advances in data generation and collection technology. Okay, because of the use of new technology in data generation and collection. So new mantra is gather whatever data you can, wherever and whenever. Meaning is that wherever data is available, you collect it. And it may be possible currently you might not be having idea that it has some knowledge or not, but it is expected that it should have some kind of hidden knowledge. So gather data will have value either for the purpose of collected. Okay, you might be aware in advance so and so kind of possible knowledge may be here, or sometimes you might not be aware. Even then, we can assume that some kind of useful knowledge is there. Okay. So this was just to show you large enormous data in different kinds of application. So here it is shown why data mining. So one is the commercial aspect. In most of the cases, we have business applications and scientific applications where this data mining plays crucial role, and even in solving few problems related to society. You will see in few next slides. So lot of data is being collected and warehoused. Collected and stored. Okay, warehouse means just storage. So web data can be, Yahoo has petabytes of web data. Okay, Facebook has billions of active users. Purchases at department and grocery store, e-commerce. Amazon handles millions of visits per day. Bank credit card transaction. Okay, so all these are few commercial applications. And again, today computer have become cheaper and more powerful. So it has made the competitive market to have an edge in providing commercial services to the clients. Okay, so provide better customized services for an edge. Okay, customer relationship management, etc. So we can have several such applications. Now, this is shown few applications of data mining in scientific world or scientific applications. So here some pictures are shown, MRI of brain. Okay, so the picture has data. Similarly, sky survey data. In sky, we have many stars, many galaxies. Okay, few are known and many are still unknown. So the pictures can be analyzed and we can use data mining there also for having some knowledge. Gene expression in biology, we have genes uh, understanding and genes expression data can be used. Okay, then surface temperature of Earth. So data collected and stored at enormous speeds. Remote sensor data, satellite images. So NASA archives over petabytes of Earth science data per year. Okay. Telescope scanning like skies and sky surveys data. Okay. Similarly, high throughput biological data, scientific simulation data. Okay. So data mining helps scientists in automated analysis of massive data sets and in forming hypothesis. Okay, so and so kind of possibility of knowledge can be. In this slide, it is shown big data. So in previous classes, I told big data is also one issue where we use data mining. Okay, so big data includes each and everything that is related to data processing, data mining, extraction of knowledge, extraction of pattern, management of variety of data, heterogeneous data. Few pictures here again. We have great opportunities to solve society's major problems. This data mining can be helpful to deal social problems. For example, here improving health care and reducing cost. Okay. Better quality of health services can be offered at low cost if we have proper study of data, analysis, and some knowledge. Predicting impact of climate change. Okay. Finding alternative green energy source. Reducing high hunger and poverty by increasing agriculture production. Okay. So these are simple, only the pictures will help you for better understanding. Data mining, we have already discussed what is data mining, but here some thing is written, so I will read it and try to understand whether it is the same as we discussed earlier or is there any difference. Non-trivial extraction of implicit, previously unknown and potentially useful information from data. Non-trivial means the knowledge should have value, weight, significance. Okay. So implicit or previously unknown pattern or knowledge should not be just like I told that common sense knowledge. If you work hard, you will get more marks. This kind of knowledge we don't require from the data mining. Okay. So the knowledge value should be significant. Okay, it has weight. So exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful pattern. So in this step, input data, data processing, data mining, post-processing, and information knowledge. So this is same as we discussed earlier, so nothing new. Now, in this slide, some information is written that is useful. What is data mining and what is not data mining? Okay. So one example is shown here. What is not data mining? Look up the phone number in phone directory. If you make a program of data mining, or if you use data mining just to search a number, just to get number from phone directory. Okay. So it is not useful, or it has no worth of use of data mining. Similarly, query a web search engine information from Amazon. So this kind of simple cases are not use of data mining. Data mining should have something like certain names are more prevalent in certain US locations. Oh, Brain, oh, Rocky, oh, really in Boston. It is just we have to find out in some areas of a country, few names of people, they are very frequently used, or they prefer to use their names on that. For example, in India, Ram name you will find very common. Okay. And similarly, in Muslim community, Muhammad be very well known. Okay. Similarly, based on community or based on geography, it is possible. So, if I want to know which surnames or titles are occurring in which area of a country or region or city, so it gives me some help use of data mining. Okay, it is suitable problem. Similarly, group together similar documents returned by search engine according to their context. Suppose when we put a search query on Google, we have large number of documents. Okay, and if I want to know which documents occurring frequently in search. So based on what kind of search I am making, and based on what kind of results are returned, and by making some kind of association analysis, I may be interested that this result was also appearing there. So this kind of problem is suitable for data mining. Now, origin of data mining, we have already discussed. Data mining is a multidisciplinary, so it uses knowledge of other domain or discipline also. So here in this diagram, it is shown statistics, data mining, and this is artificial intelligence, machine learning, pattern recognition. So these three, this domain and this domain, statistics and these AI machine learning, the knowledge present in this domain, they are very frequently used here. So database technology, statistics, machine learning, artificial intelligence, pattern recognition, and knowledge from other domain. Okay, so all these constitute data mining. So data mining task, we have discussed prediction and description in earlier classes. So use of variable to predict unknown or future values of other variable, and description to find human interpretable patterns that describe the data. Simple description. Okay. Now you see here, if I try to show the demonstrate use of data mining technique. So this is the large data, and we can apply clustering. Okay, clustering techniques can be used. Similarly, uh, predictive modeling, just classification model can be generated and prediction can be made. Similarly, association rules can be, and anomaly detection. So this is just showing picture use of data mining techniques or task by diagram. Okay, so I go to the next one. Find a model for class attribute as a function of the values of other attributes. So simple problem we discussed about the classification. Here one example is shown. This is the data set. Okay, here in data set we have several attribute: employed, level of education, year, at present address, okay, number of years. So where stay period can be here. So and credit worthy, that means the person is just like if you go to a bank for loan. Okay, so bank has to take decision whether it will be good to give you loan. Okay, whether you will return loan honestly or not. So this kind of guess the bank manager want to have. So what he or she can do, the large data set of past in his bank or other bank whatsoever, and the decision tree class diagram or this can be developed. Okay, and based on whether loan should be granted or not, or the worthiness of credit model for predicting worthiness, credit worthiness. So person is so here it is employed. If person is not employed, so certainly whether he will return loan or not cannot be guaranteed. Okay, but he is employed. Then next test is person is educated. So if he or she is graduate, okay, then if he is or she is staying more than 3 years in a city or less than 3 years. So if 3 years, then the person is supposed to be a reliable person according to this pattern. Similarly, here if person is less educated and high school and undergraduate, okay, then next is the number of year duration of staying more than 7 years, less than 7 years. So this is one simple example how the classification data can be used to make prediction. So by diagram we show like this. This is the data set. By this data set we train, or this is also called training data set. So we develop or we train a model. So this model is prepared and then we take any unknown data or new data and we or we can also write here test data and we predict. Okay. So the problem can be represented through diagrams like this. Okay. Now examples of classification task. Examples, few more examples are given here. Classifying credit card transactions as legitimate and fraudulent. Fraudulent. Okay. So whether the credit card holder is legitimate or there are chances of fraud. Okay. So next is classifying land cover, water, water bodies, urban areas, forest. So satellite image can be studied and based on that. And categorizing news stories as finance, weather, entertainment, sports. Okay, so news stories can be categorized based on identifying so-and-so features by use of data mining, identifying intruders and the cyberspace. Okay, predicting tumor cells as benign or malignant. Benign means harmless and malignant means harmful. Okay, so not tumors are supposed to be harmful. So this is in medical science people use. Classifying secondary structure of protein as alpha helix, beta sheet, or random coil. So this is terminology used in medical domain. So we are the examples. Here one example is shown how the problem is formulated. That is, if we have to deal a problem, then what can be the possible approach? Suppose fraud detection. So predict goal is to predict fraudulent cases in credit card transaction. Okay, so fraudulent cases in credit card transaction. What is the approach? Use credit card transactions and information on its account holder as attribute. Okay. So we are taking here transactions and account holder information. When does the customer buy? Okay, purchases. What does he buy? What kind of item he or she purchases? How often he pays on time? ठीक है, etc. So this information can be used. Label past transaction as fraud or fair transaction. Okay, this forms the class attribute. The classes we finally want here as label can be fraud or fair transaction. Okay, learn a model for the class of transaction. Use model to detect fraud by observing credit card transaction on an account. So in this way, we make a classification model, and that has two classes here, fair or fraud transaction. Okay, based on so and so a study of attribute, and we apply data mining technique classification. Okay, so this is one example, and what can be the possible approach. Similarly, it is another example here how we can go ahead, what can be the possible approach for the solving this problem. Churn prediction for telephone customer. Okay. So goal is to predict whether customer is likely to be lost to a competitor. Here meaning is that currently a customer having or customer is a client of so and so company. Okay. So in future time, this customer will continue with the same operator, or the customer is going to change the service operator. Okay. Or how long the customer will retain with the current telecommunication service operator, like that. So here the approach can be use detailed record of transaction with which of the past and present customers, okay, to find active. First of all, we study the transaction and their attribute. So it is called relevance analysis. Okay, which attribute are relevant for my study. So first step will be relevance analysis. So we are Here we are trying to find out the relevant attribute, how often the customer calls, where he calls, what time of day he calls most, his financial status, marital status, etc. These are the relevant attribute here. Label the customer as a loyal or disloyal. Find model of loyalty. Okay. So here the loyalty term has been used. Okay. So you have to understand before formulating the problem the terminology used in the domain, the meaning of each terminology, and how it is being used in the domain. Okay. Then you will study based on or from the standpoint of data mining the attribute. And by completing relevant analysis or relevance analysis, you will be able to know so and so attribute need to be considered and so classes or class names labels will be suitable here. Okay, so this is the common in all. Okay. Sky survey cataloging goal here and approach. So goal is written to predict class star or galaxy. Here two classes we are considering of sky objects, especially visually faint ones based on telescopic survey images. Some image data is shown here. 3,000 images with so and so pixel per image. Segment the image. Measure image attribute features 40 of them per object. Here 40 attributes have been mentioned. Okay. So image features and other things that may help in constituting the model and predicting whether it is a star or galaxy like. Model the class based on these features. Here something is written, success story. Could find 16 new high red shift actually it is a astronomy term. Okay, quasar. Okay, so some astronomy object name is there. Okay, I don't know details. So some of the farthest objects that are difficult to find. So it is saying that 16 such objects could be or were detected. Maybe star or galaxy whatsoever. So here simply meaning is that the data mining study of the data set of 3,000 images. Okay. Based on the features of 40 relevant attributes. Right? So it was observed that 16 such new objects were identified. Okay. So this is another example. In this slide it is shown. Early this was, intermediate and late. Stages of formation, attribute, image features, characteristics of light, wave received, etc. Okay. This is the website address. You can go here and more information you can get there. Here our objective is in image data. It is also successfully this data mining can be applied. Next regression we have already discussed. So just I read this slide. Predict a value of a given continuous valued variable based on the values of other variables, assuming a linear or non-linear model of dependency. Extensively studied in statistics neural network fields. Okay. Example, predicting sales amount of new product based on advertising expenditure. Predicting wind velocities as function of temperature, humidity, air pressure. And time series prediction of stock market indices. Okay. Clustering we already discussed. It is like a grouping of objects close to each other. So here this is forming three clusters, and inter-object or intra-object relationship. So inter-cluster distance is minimized. That means this distance among or between the objects of the same cluster, and this is inter-cluster distance is maximized. Okay. Here it is shown physical distance, but actually it is a measurement of attribute. We will see in other subsequent classes how they are measured. Okay. So simply similarity or dissimilarity here. Now, example of cluster analysis, few applications here. So, understanding custom profiling for targeted market, group related document for browsing, group genes and proteins that have similar functionality, group stocks with similar price fluctuation. Okay. So data are studied and based on here by different colors, similar or dissimilar data have been shown. Okay. Then class labels, class diagram, summarization, reduce the size of large data set. Okay. So simply, when we do not have any knowledge about the data labels, okay, the first step will be the clustering. And by using clustering, when we know so and so are the appropriate data labels, then we can prepare a classification model. Few examples of clustering are shown here. Market segmentation. Your goal is subdivide a market into distinct subsets of customers, where any subset may conceivably be selected as a market target to be reached with a distinct marketing mix. Okay. So here we want to divide market into subsets. So market subset means subsets of customers. Okay. So collect different attributes of customers based on their geographical and lifestyle related information. Find clusters of similar customers. Measure the clustering quality by observing buying pattern of the customers in same cluster versus those from different clusters. Okay. This is another example, document clustering. Here goal is to find groups of documents that are similar to each other based on the important terms appearing in them. Okay, we have documents and in each document few terms occur frequently, repeatedly. Okay, so some kind of this study, it is possible to apply the clustering technique. So here it is written to identify frequently occurring terms in each document. Form a similarity measure based on the frequencies of different terms. Use a cluster. Use it to cluster. Okay. Few documents are related to politics. Few documents are scientific documents. Few documents they are from Bollywood or Hollywood film industry like that. Okay. Few documents are having crime information. So all these documents I want to categorize. So one possibility, one person should go through each document one by one and categorize. But it is a very time consuming process. There are millions of documents. So we have to develop some automated solution. So this is the technique. Now association rule discovery, we have already discussed association rule mining. Okay. We have data items, transactions. So they are the names of the applications. And we discussed in the beginning for um, promotion of the business sale or making or studying the customer behavior pattern of purchasing, like, so that strategies could be designed by the businessman. Okay, so this is another example. This is for patient of cancer. So cancer patient data has been studied here, and genes of the cancer patient have been studied. So here it is on 102 cancer patient, and out of that 67 normal patients, some kind of this normal or abnormal. So based on this study, some kind of knowledge can be extracted. Example of subspace differential co-expression pattern from lung cancer dataset. So detail we cannot discuss here. So this is just one example in medical science. This is another example, deviation anomaly detection. Okay. So some application, credit card fraud detection, network intrusion detection, identify autonomous behavior from sensor network. I close now. Anything you want to ask, you can ask. So in this way, this chapter is over.